Now we are going to hear a lot about DNA. DNA is natural material that we find in all cells. The greater part of the cell nucleus, the chromosome, is built from DNA. DNA is made of chains with several links which are built from the 4 different bases: adenine, thymine, cytosine, and guanine. Apart from this, DNA is also built of a sugar molecule called deoxyribose and phosphorus groups. The protein synthesis consists of 2 steps: transcription and translation. The transcription happens inside the cell nucleus. The DNA will be made into RNA. The RNA will then become mRNA, but before it can go any further, the rmRNA must be made into a mature mRNA. The mature mRNA goes into the ribosome, and inside the ribosome, the process where the protein build-up happens. This is the part that we call translation. Now we will describe the different things. First of all, we will go through the transcription. That happens here is that we have a DNA line, and inside the DNA line is the sequence that we are interested in, so we can make our desired protein. What happens here is that in the enzyme RNA polymerase come in and take a copy of the sequence in the RNA code instead of the DNA code.
The RNA code will become to our pmRNA. Our pmRNA consists of some different pieces. Exon is a smaller DNA code and intron is a bigger non-DNA code. The intron will be spliced away so that we only have a chain with exon. Smaller DNA code and the full DNA code. So here we have the major rmRNA. Now we have our major mRNA. Can we put it into our ribosome? Here it works as a template for a desired protein. The process is called translation.
Here we have 2 similar genes that makes you either taste or not taste the bitterness of the PTC paper. But in the 145 link there is a mutation, or as we call it, SMP. SMP is short for single nucleotide polymorphism. The capital letter T is the name of the gene that makes a taste receptor where the PTC has the possibility of attaching. Because it's able to attach, it's able to send signals to the brain that makes it taste bitter. The small letter T is the name of the gene that makes a taste receptor where the PTC does not have the possibility of attaching. Because it can attach, it's not able to send signals to the brain that makes it taste bitter. Therefore, will people with this gene not be able to taste anything. If you both have the capital letter T and the small letter t in the name of your gene, you would both have a taste receptor that can and can't attach to the PTC. It doesn't mean that you aren't able to taste the bitterness, but something that the taste is weaker than if you have 2 capital letter T. So the 2 capital letter T's are dominant together with the one with the capital T letter and the one with the small t. That means that the one with the 2 small letter T's are recessive.
We have tried the PTC paper to research which genes we have. Judith didn't taste anything but the paper, so that means that she has 2 small t's. That means that she has SNP. Maria did have a reaction to the PTC paper, and she did taste the bitterness, so we are pretty sure that she has the 2 capital letter T's. Mie, on the other hand, did have a slightly milder reaction than Maria, but still enough to conclude that she has at least 1 capital letter T in her gene.